This is Unit 5, Lesson 6. We're going to talk about how to divide polynomials. We've done addition, subtraction, multiplication before, so now we're going to talk about how to divide them, and it's a little bit trickier. So the first thing is just a recap. We've done this before when we did our polynomial chapter. Dividing by a monomial is pretty straightforward because you have just one thing that you need to divide. So we're going to look at number 2. We're supposed to be dividing all of this by 7ab. So it's almost like you're distributing the division. It's like you divide this by 7ab and then this and then this. So let's do that just to remind you how it works. So divide each piece by itself. So 21 divided by 7 is 3. A to the 5th divided by a. Remember, that works like subtraction. So like this is technically an exponent of 1. So 5 minus 1 leaves me with 4 copies. And then b to the 3rd over b, 3 minus 1 leaves me with 2 copies. So that's the first one. Then you move to the next one and just divide each piece. So negative 14 divided by 7 is a negative 2. A cubed divided by a is a squared. B squared divided by b leaves us with a b. And then finally the last piece, divide all this by 7ab. 63 divided by 7 is 9. A squared divided by a leaves us with an a. And b divided by b is just 1. So we think of that like it's canceling, so you don't write anything down there. So this is as simplified as it'll get. None of those are like terms, so nothing combines. And so that is your answer. So dividing a polynomial by a monomial is fairly straightforward, and we have done it before. If you're dividing by a binomial, there are 3 different methods that we're going to look at. One is only available in certain cases. It's only available if you're able to factor. So we're going to look at number 3. We can use factoring to divide. So if you look at this numerator, it's just a pretty traditional trinomial like we've been factoring during this unit. And so we can factor this out. So this is the numerator. So w squared is going to be w times w. And then remember the way this trinomial pattern works. We're looking for 2 numbers that multiply to 10 and combine up or add up to a negative 7. And that would be a negative 5 and a negative 2. And then our denominator is just linear, so it doesn't factor. So we think of the w minus 5 as like one factor. And hopefully you notice as you're looking at this, the numerator and the denominator are the exact same. So if you have this exactly identical matching factor, you're able to cancel them out the same way that we were able to cancel out b over b. So this is w minus 5 over w minus 5. No matter what you plug in for w, it's going to be the exact same number. And so it divides out to just 1. So we can say that it's canceling. And so your answer that's left behind is the factor w minus 2. That's great if you're good at factoring and if it is factorable, but most of these are not going to be factorable. Okay, so then we get down to this next category right here. What if factoring is not possible? And that's usually the case with what we're going to be looking at here. So we have 2 different methods. Method number 1 is long division. If you learned like division of numbers by using long division, then this should be a very familiar process for you guys. So I am going to put a little sticky note on here and just do a long division problem, take you guys back to like 6th grade if you did it like this. You don't have to write this down. I just want to remind you of the steps. So let's say that we take 643 and we want to divide it by 10. All right, so hopefully this setup looks familiar to you. So we're taking 643 and we're dividing it by 10. So you move term by term. We look at the 6. Is the 6 divisible by 10? It is not, so we move on. Then we look at this like a 64. Is the 64 divisible by 10? And you want to see how many times does this 10 go into 64? And it goes in 6 times. Not evenly, but it can go in a maximum of 6 times. So you put the 6 right here. Hopefully this is looking familiar. And then after that, you take this 6 that you have up here, you multiply it by the 10 that's over here, and you subtract that. So 6 times 10 gives us 60, and we subtract that. So when you subtract, the 60 part will kind of cancel, and then you just have 4 minus 0, which is 4. So you do the subtraction. That's kind of the end of round 1. And then the next thing you do is you look back up here, you take the next term, and you bring it down to the level that you're at right now. So this 3 gets brought down right here, and then you repeat that process until you run out of numbers. So this 10, we look to see how many times it can go into 43, and it goes in a maximum of 4 times. So we write the 4 up here. And then you take that 4, you multiply it by 10, which gives us 40, and you subtract that. Okay, so 43, the 40s kind of cancel. The 3 minus 0 leaves us with 3. And then we don't have anything else to bring down. We're not going to do decimals with this because with polynomials, you really can't do decimals. We're going to do remainders. So the way the remainder works is you take this as your remainder and you put it over your divisor. So we would write 3 over 10 as our remainder. So your answer is 64 and 3/10. So I'm going to leave this on the screen off to the side just so I can flash back and remind you how numerical long division worked so we can compare it to polynomial long division. So we take the thing you're dividing by and you put it out like this, and then everything else goes under the little division sign, just like that. And what you're dividing goes underneath here. I should have left a little bit more space up here. I'm gonna have to squeeze some things in. So this, we tried to divide 10 into 64. Here, we're gonna try to divide this into x squared. And the thing that's important, and the thing that mixes people up a little bit is you don't wanna use the whole x plus 8. You kinda just wanna use the x right here. Okay, so we're just using the x. We wanna see how many times does x go into x squared. In other words, I want you thinking x times what gives me x squared, okay? X times what gives me x squared? And that would be an x, so I put that up here. Remember, x times x gives you x squared. So then, just like this, we took the 6, we multiplied it by 10, and we subtracted that. So here, we take the x, we multiply it by this, and we subtract that. So x times x plus 8 would be x squared plus 8x. You're distributing it. So x times x plus 8 is x plus 8x. And just like this, we subtracted. So you subtracted, but you want to be super careful that you're subtracting the whole thing. So always make sure you have parentheses. Otherwise, you'll probably make a sign error. So here, these, like the 6 is canceled, and then we just did 4 minus 0. So here, the x squareds cancel, and we do 3x minus 8x. Be super careful with the subtraction. So 3x minus 8x is a negative 5x. And that's what I'm left with from that step. And then here, after we had the 4, we took the 3 and we brought it down. So here we're going to take the minus 43 and bring it down and form a new polynomial. And then we repeat that process again. Over here we said, how many times does 10 go into 43? So over here we're saying, how many times does x, remember you only look at the x, how many times does x go into a negative 5x? Or in other words, what do you multiply x by to get negative 5x? And that would be a negative 5. X times negative 5 gives me negative 5x. So I put a negative 5 right here. Sorry, I did not space that appropriately. And then you take this, multiply it over here, and subtract it. So negative 5 times x, and then negative 5 times 8. And you subtract that, which means we need parentheses that we're going to be super careful with our signs. Line this up. These will cancel. And then we have negative 43 minus a negative, so plus 40. So my remainder is a negative 3. There's nothing else to bring down. Once I get down to the end, I write my remainder over my divisor. So I have the x minus 5 from up here, and then I have a negative 3 as my remainder, so I write negative 3 over my divisor, which is x plus 8. And that is my answer for my first round of long division. All right, so I'm going to get rid of this. We're going to compare the exact same problem and learn a different method. This method is called synthetic division. It's kind of a little shortcut. So you can't see everything happening the way you can here, but a lot of people prefer this because, like I said, it is a little bit of a shortcut. So what you do here, you take these 3 coefficients, only the coefficients. So x squared is like a 1x squared. 3x is like a 3. Negative 43, put that right here as well. So you take just your coefficients, and it's really important that they're in the right order, and it's really important that you account for everything. So we're going to keep them in a little box. All right, we're going to keep them in a little box. We've got this, the x plus 8. So we set that equal to 0. We have like x plus 8, and we set that equal to 0. That gives us negative 8. So this is what we're going to put in a little box. So we take the opposite of this, put it in a little box, and then we line up all the coefficients here. So it's just this process that you sort of have to memorize. A lot of times people like this better though. Okay, so it works like this. Very first thing that you do is this coefficient just gets brought straight down to the bottom. Okay, no matter what's here, you just drag it down to the bottom. And then it starts this process of multiplying and adding. and multiplying and adding. So we take this one and you multiply it by the -8 from the box and you line it up right here. Okay, and then we add these two together. And when we combine them, we get a -5. And then you repeat. You take this -5 and you multiply it by this -8, and that gives you 40. And you put the 40 right here. And then you combine these up. When you combine these up, you get a -3. So all these numbers appeared over here somewhere. Like the 1 just got brought straight down. This, we did combine a 3 and a -8. This was the 3x minus 8x. And this -5 is this -5x. And then we saw this happen too. The -43 combined with 40, that was this. The -43 minus a -40 gave us that -3. So like all the pieces are still there. You just kind of remove all the variables to make it like this little shortcut. And the reason this 8 is negative instead of positive is to account for the subtraction that we're supposed to be doing. So the -8 means that we're subtracting the values that we're supposed to subtract. Okay, so now these are the coefficients for our new polynomial. So I highly suggest starting at the end and working your way back to the left. So the number on the end is always the remainder. All right, the number on the end is always the remainder. So we're going to take that remainder and put it over our divisor, which is x plus 8. And then next to that is always the constant. So the -5 is the constant we put right here. And then the one next to that, then the powers just start to increase. So if this is the constant, this is the x. So 1x would just be an x. If you had more, it would be the x squared, the x cubed. It would just start going up from there. So this is exactly what we got by using this method. So two different methods, exact same results. So those are our two methods. On the next page, we're gonna just practice a couple more and you guys can pick your method. I'll make sure that I'm kind of showing you a little bit of each. So on this next page, we're gonna do number 7. All right, so number 7, we can do either long or synthetic division. For this one, I will show you both. All right, so this, I'll do the long division. Take the 2n squared minus 16n plus 19 and divide that by n minus 7. Now, I am never gonna tell you to choose one over the other, so whichever one you like better, just stick with that one. All right, so it goes like this. How many times does this go into this? Or what do I multiply by this to get this? And that would be a 2n. Then multiply down here, 2n squared minus 14n. And make sure you subtract. So when I subtract, these cancel. -16 minus a -14 leaves me with a -2. Bring down that 19 and repeat. How many times does this go into this? Or what do I multiply this by to get this? And that would be a -2, which goes up here. Take -2 and multiply it here. -2 times n, -2 times -7, and then subtract. These cancel, and then we have 19 minus 14, which is 5. So that's my remainder. I write this, 2n minus 2, and then I put my remainder over my divisor. So a positive 5 over n minus 7. So that's my answer from doing long division. I should get the exact same answer by doing synthetic division. So let me show you. Take your coefficients and line them up. We have a 2n squared minus 16n plus 19. Take the opposite of this number and put it in a little box. So if it's n minus 7, you should have a positive 7 in a little box. That accounts for the subtraction that we were doing over here. So this first number just gets a free pass down to the bottom, and then we start to multiply and combine. So combine these, that gives us a -2. Then we multiply and combine, and that gives us 5. So now when you're writing the answer, I suggest you start from the back. So there's a 5 is our remainder. We put that over the divisor of n minus 7. It's positive. And then -2 is the constant. And this 2 is the x term, so you attach it to an x. If you had more, it would be x, or I'm sorry, this should be an n. Should be an n, since that was our variable. So same exact answer, two different methods. All right, we're gonna look at one more. We're gonna look at number 9. This is a special category here when you're missing powers in the dividend. So this is our dividend right here. Notice it jumps from a k cubed to just a k. There's no k squared. So little note that we need to make ourselves here is you are going to add in any missing powers as zeros. Okay, so we're gonna put like a 0 k squared in its spot. Okay, so set up your long division. We have k to the third. We're going to put in a 0k squared minus 17k. The lineup is super important, so it is extremely important that you account for anything that's missing. And we divide by k plus 5. Okay, so how many times does k go into k cubed? Well, k times k squared gives us k to the third. So multiply and subtract. K squared times k squared times 5. So see how important it was to have this as like a placeholder here? Because now everything's all lined up. If this was lined up under here, I wouldn't be able to combine it. We'd get all confused. So these cancel. 0 minus 5, k squared. And then bring down my next term. Just the next one, not everything else. This one's a little longer than the other ones. How many times does this go into this? This times what gives me this? That would be a negative 5k. So I multiply negative 5k to the k plus 5, and I subtract. So negative 5k squared, negative 5k times 5 would be a negative 25k. Subtract, these guys cancel. I have negative 17 minus a negative, so plus 25k, and that leaves me with 8k. And then finally, bring down that 32. So one last time, what do I multiply k by to get 8k? That would be an 8. Multiply 8 times k plus 5 and subtract. So I have 8k plus 8 times 5 is 40. And subtract. These guys cancel. I have 32 minus 40, which is a negative 8. So we're not doing this problem, so I'm just going to get it out of our way so I can write the answer. So the answer is all of this stuff, k squared minus 5k plus 8, and then you write the remainder, negative 8, over the divisor, which is k plus 5. So that is our answer using long division. And finally, one more time, we'll do the synthetic division. So you take our coefficients. We have a 1 k to the third. We do not have a k squared, so you have to put a 0 there or everything will be messed up. Negative 17k and 32. And then this k plus 5 means we put a negative 5 in our little box, and then we can run through this process. So remember, the first one gets a free ride down to the bottom. Then you multiply, combine, multiply, combine, multiply, and combine. So these numbers should look familiar because they're the same numbers we kept coming up with over here, like the 25k, that's the 25. The 40, that's the 40. So write everything from right to left. So negative 8 is your remainder. So we write negative 8 over the divisor of k plus 5. To the left of that is the constant. So we have just a plus 8 right here. To the left of that is the x term. So that's a negative 5 times x, but it's actually a k. And to the left of that is the x squared term, or the k squared term. So it's a 1k squared. And again, pay attention here, it should be the exact same. So you guys get to pick. If you very much preferred one over the other, just feel free to do that the entire time.